Combining like terms. This is a skill that you may need to use with a simple expression, meaning no equal signs, just a whole bunch of numbers and variables together. Or you could be using combining like terms when you're solving equations, multi-step equations, variables on one side or both sides of an equal sign. The first step is to be using these grouping symbols. Grouping symbols could be rectangles that you use, could be circles that you use, and you're going to put circles around like terms and you're going to put boxes around like terms just to help organize your thoughts. Just remember that these like terms, they need to have the same variable and the same exponent, identical variables and exponents. The numbers next to them don't matter in the beginning, but you need to make sure that the variable and the exponent is the same in order for them to be like. And then when we're done, we're going to combine those like terms. Let's make sense of what I just said. So we have 3x plus 4x squared minus 2x squared plus 7x. Well, remember, they're all x's. Step one was making sure that they have the same variable. And in this case, a variable is any letter of the alphabet, really. And we have x, 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 x. They're all the same. But the second step was to make sure that they have the same exponent. For instance, I'm going to circle this 3x, right? Are there any other regular x's? No exponents. Well, on the other side, there's a plus 7x, right? The x squareds don't get grouped with these because these are just regular x's, right? And then what else can we group? Well, we have x squared, x squared. So these two terms we are going to group together because they both have x to the second power. Now when we're combining these terms, we're going to group the red circles together, in other words. We have a 3 plus 7. So how many x's do we have? Altogether, we have 10 x's. The x doesn't change. Now we look at the numbers to the left of those variables. 3 plus 7 equals 10x. And then, same with the blue circles here. We have a positive 4x squared minus 2. So 4 minus 2 would be 2x squared. But once again, 4 minus 2 is a positive 2. So in between those two values, we put plus 2x squared. So believe it or not, this is going to be our final answer to the question. We can't solve these, but we can simplify these expressions. And moving on from here, let's go on to example number 2. Combining like terms, look for the same variable. We see a bunch of r's, and they are all regular r's, not to the second power. So we have 10r, we have a negative 3r, and we have a minus r. None of those r's are to the second power. None of them are r to the third power, anything like that. So we can actually group all these together. So 10 minus 3 is 7. And minus 1 more would be 6r. All right, how many r's do we have? We have 6. Remember, 10 minus 3 minus 1 more. We actually have to stick, it's like a negative r is a negative 1r. So we're actually subtracting 4 out of that 10 to get 6r. Other than that, we can combine regular numbers. Our rule isn't just for variables, regular numbers. If I said to you 4 plus 1, a positive 4 and a positive 1, you would absolutely tell me it's a positive 5. So 6r plus 5 is our answer in simplest form for this question. The last example I'd like to go over with you is a little bit more complex. We need to know a little bit about integers and some more of the negative rules. But how many p's do we have? We have a negative 10p. All right, where are all the other regular p's? There are no exponents, so it's a little bit easier in that regard. But what is a negative 10 minus 2? All right, if you think about negative 10 on a number line, and if we subtract 2 more, we're going further to the left on that number line, so we actually have a negative 12p. And then we do still combine our r values. We have a positive 7r. We have a negative 2r. So a positive 7 minus 2 would give us a positive 5. We just subtract 2 from the 7 and we get a positive 5r. So there's our final answer. We have simplified this expression as well.